was a good try. All right. Brian.
Hey,
Are we
shut
gonna
up.
start it with you in?
It already started, Don.
So, step 1. Prove that the function is continuous on that closed interval. So think about a cubic function. A cubic function in general is continuous. So now all we've done to our cubic function is shrunk it from 0 to 2. So number 1 for Rolle's theorem would be true, because it would be that f is continuous from the closed interval 0 to 2. Number 2, would f be differentiable on the open interval? So can we derive a cubic into a quadratic?
Yeah.
And it's going to be differentiable everywhere on that quadratic?
Yeah.
So f is differentiable from 0 to 2. The third thing, which is probably the hardest one to prove, is that f of a equals f of b. Meaning that the beginning of the interval and the end of the interval have to be equal. So this function cannot be 1-to-1 in order to be f of a equaling f of b. So we need f of 0 to equal f of 2. And again, you're plugging into f, not f prime. So 0 minus 0 plus 0 plus 5. 2 cubed is 8. 2 squared is 4. 4 times negative 3 is negative 12. 2 times 2 is 4. What do you know about 8 plus 4?
It's
Negative 12.
It cancels out with 0.
And then you get 5. So those cancel to give you 0 plus 5. So f of 2 is also 5. So now, what we've proven is that f is continuous, f is differentiable, and f of a equals f of b. That means that there exists a number c that is a critical point between a and b. So that means there's a critical point between 0 and 2 on this function where f prime at c will equal 0. So what we need to do is find f prime of x. So 3x squared minus 6x plus 2. And then what this says is that f prime of c will equal 0. So what we're going to do is we're going to turn this to a 0, and we're going to turn all those x's to c's. And then we're going to find that c that exists between 0 and 2. So factor this, which it's not factorable, right? Because there are no factors of positive 6 that will sum to negative 6. So quadratic formula. So 0 equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
So, not going to be 3. Because you get squared 4.
Yeah. So, but all you need to do, we don't need the number to be great. All you need to do is show that the number is between 0 and 2. So you do 6 plus square root of 12 all over 6. Yep. And then do 6 minus square root of 12 all over 6. So are both of those in my closed interval?
Yes.
So these two values, or this very unestimated value, are the points C that satisfy f prime of C equals 0 and are the critical points of this problem. So more than likely, if you did a sign test, which we're going to get to in 4.3, this would show like local mins and local maxes. So all those are critical points, and they're guaranteed to be a critical point. Okay. So the mean value theorem is now an extension of the extreme value theorem and Rolle's theorem. And the mean value theorem has the same 1 and 2. What changes is what we get from it. So now, what does this right here look like? What's this equation? What's that f of b minus f of a all over? Yeah, that's the slope of the secant. So the mean value theorem is now creating a connection between f prime of c and the slope of the secant. So what the mean value theorem says is that there is a number c that lies between a and b such that the derivative at c is equal to the slope of the secant. So again, in layman terms, the mean value theorem states that there is at least one point C on F where the slope of the tangent equals the slope of the secant. That is the big picture. Slope of the tan equals slope of the secant, which we have not yet had happen. We've looked at the slope of the secant for average rate of change, and we've looked at the slope of the tangent for instantaneous rate of change, but we have not had an example where the average rate of change equals the instantaneous rate of change. Well, if you got that as a question, mean value theorem would allow you to prove it. So the mean value theorem would say that the slope of the secant equals the slope of the tangent if f prime of c equals f of b minus f of a. So, in order to explain that, we have to explain why each of the following functions fail to satisfy the conditions of the mean value theorem. So, what we want to do is we want to look at a piecewise function. Did it jump too far? Like, did it finally? I was going to say, like, I didn't feel like. So, what we want to do is still look at 1, 2, and now my 3 is a little bit different. My 3 is to find f of b minus f of a all over b minus a. So number 1, would this cubic function be continuous on the closed interval -1 to 2? So, to prove that the theorem is true, you have to write 1, 2, and 3. So you have to say f is continuous from -1 to 2. If it's continuous, is this function going to have any sharp points? Are there any absolute values or anything in there that's going to make it not differentiable? No, this is cubic. So polynomial functions are going to be continuous and differentiable always. So it is differentiable from -1 to 2. Here's where the 3 is different. I no longer need f of a to equal k to equal f of b. Now what I want in 3 is to find the slope of the secant. So I want to find f of b minus f of a all over b minus a. So what that means we're going to do is we're going to find f of 2 minus f of -1 all over 2 minus a minus 1. So f of 2 is 8 plus 8 minus 2. 14. And then you're subtracting negative 1. So you get negative 1 minus, or plus 2. So you get positive 1, and positive 1 minus 1, let's say 0. And then in your denominator, you get 3. So, now find your derivative of f.
It should be minus 2.
I was going to say, I didn't feel like it was 0.
Because negative 1, like if you plug
Plus
negative 1,
2
it's 1 plus 1.
minus a minus 1. I was like,
I saw your wheels check.
now, find your derivative. So what's f prime of x?
3x squared.
Here's the difference. What I want to occur now is I want f prime of c, for the critical point, to equal the slope of the secant. So instead of setting this equal to 0, I am now setting it equal to 4. So what we're going to do is we're going to say 4 equals 3c squared plus 4c minus 1. And what that's doing is that's giving you a critical point where the slope of the tan equals the slope of the secant. So remember, in order to solve a quadratic, it has to be set equal to 0. So I have to subtract that 4 to the other side. Because there's no factors of 15 that are going to sum to 4. So, quadratic formula again. Or 2 squared is 19. Is 76 divisible by 4? So the square root of 4 is 2.
Oh, okay.
Not that it matters. Because, once again, these numbers, the only thing we care about is their approximation. Because we want to know if their approximation is in that interval. So you do the negative 4 plus 2 square roots of 19 all over 6. You should get 0.7862. And then do negative 4 minus 2 square roots of 19 all over 6.
You know, you taught us to factor the quadratic with the number outside the first term, and you have to multiply the first and the last. And well, in trig last year, I had to show this basically how to do it like that. She had never done it like that.
It's because it's not in between negative 1 and 2.
Good. So the only value of c that works, that will make the slope of the tangent equal the slope of the secant, is negative 4 plus 2 square roots of 19 all over 6. We'll do the rest tomorrow.
We still have 10 seconds to waste. You just have to laugh when you did it?
It's